everyone, and welcome to Discover Engineering's Chats with Changemakers. I'm your host, Kavya, and I'm a 12th grader in New Jersey. And every month, I welcome a different guest from the engineering community. As the holiday season kicks off, the spirit of joy is everywhere, and we are reminded of how far we have come in 2023. Chats with Changemakers has been a year-long journey of learning, inspiration, and positivity for all of us. And we hope that you carry that with you to the holidays and that you continue to explore the possibilities of engineering. Today, I am chatting with Jay Abbott. Jay works at McCarl's as a field engineer in the minerals and metals industry. Jay, welcome. Thank you so much for joining us today.
Yeah, hi, Kavya. Yeah, thanks for having me. Super excited to be part of the program.
Definitely looking forward to our conversation. I'm going to be asking Jay a few questions to get to know a little bit more about him. And you can ask questions too by typing them in the Q&A box below. And we'll save some time to answer as many as we can. Okay, so let's get started. First of all, Jay, can you please provide an overview of McCarl's and your role at the company?
Yeah, sure. So McCarl's is an industrial contractor. We provide construction and engineering services to industries such as power plants where they generate electricity, gas and oil plants that provide fuel for vehicles and power plants, steel metal factories where they melt metal and ship metal all over the world.
Wow, so it seems like a wide range of functions and projects that you're working on. So what inspired you to be a field engineer, and how did your educational experiences influence that path?
So I started off after high school joining an apprenticeship program where I served a 5-year apprenticeship to become a journeyman pipe fitter. So pipe fitters install mechanical systems and engineers design and provide water, heat, energy through pipes and equipment. In my apprenticeship time, I would only go to school for 2 days a month. So every other week, I'd go to school for a full day, and all that other time was spent out in the job learning how to install these systems. I spent about the last 20 years with McCarl's, where I came to work with them as a pipe fitter, and then moved into positions as like a foreman or supervisor. Once in those positions, the company started to research equipment and technologies like laser scanning and robotic total stations. And I was in a position, me and a few other guys, that we had the opportunity to get our hands on this cool equipment and just start learning how to use it and where it fit in the construction world. It took a few years to implement it and get it out in the jobs and get people to bought into what the equipment does and how it benefits construction. It's really been a game changer for our company. We've been able to take the equipment and do jobs a lot quicker, more accurate, and save our clients a lot of money in the end with utilizing it.
That's interesting. And I think you mentioned a lot of real world experience and on the job learning. So I think that it's made your journey very unique. And another aspect that I found fascinating was how you've been able to adopt emerging technology. So that kind of leads into my next question. Your current research at McCarl's is focused on leveraging technology like drones and laser scanners for projects in the minerals and metal industry. So could you please tell us more about these real world applications?
Yeah, so like I was saying, with using the laser scanners out in the construction sites, we take a scanner out, and the scanner is set up on a tripod, and the scanner, once we start it, will spin 360 degrees and capture all of the data that it sees in that position. Then we move it to several other positions, and in the end, we take all of those positions and merge them in together to create a whole 3D environment. From that environment, we can take it back to the office and put all it into a computer, into an AutoCAD program or any types of 3D modeling programs, and start modeling our systems that we want to build, to those point clouds. So there's a little bit more time spent, in the front end of a project to go out there and do that. But once we do it, we have all the data in the computer, and nobody has to go back out to the job site to take measurements or to climb up ladders and scaffolds to measure piping systems. So from there, we call it reverse engineering. So we can take the data, engineer to a real world environment, and make everything fit right where it belongs. So we have terrestrial laser scanners for doing the practice, like I just explained, and we have drones. So recently, over the last 5 years, we implemented using drones to capture larger footprints. So like the whole facility, a 100-acre, 300-acre facility, we can fly with a drone in 1 or 2 days and capture all the 3D data from the outside. And that gives us and the owners the ability to access all of that data, again, from the computer, from within the office, and not have to have multiple returns to site to verify things. The drone also gives us the ability to access areas that might not be safe for personnel. Getting up on a rooftop, or getting into an area where there's chemicals and heat. So the data is captured safely and accessed behind a computer. On top of that, we use something called a robotic total station, which is survey equipment, and they all kind of go together in some fashion. The total station is a survey instrument that only shoots single points. So once we capture all that data, we build our systems and we design it, and now we got to go back out and install the systems. We'll use a total station, a survey instrument, and set that up. And this total station will tell us exactly where to put the stuff that we designed. And it all, from the start to finish, is we just mastered that workflow, and it's been great. The one thing the kids might like is that whole 3D environment. Everybody's into virtual reality and augmented reality, and once we're all done, we can put on a set of VR goggles and sit there and fly through the power plant or whatever, and look at our piping and make sure everything looks right and fits right, and it becomes fun at that point.
That sounds incredible. How technology is just part of every stage in the process, and how you've been able to optimize that workflow with all of this. So we have our first audience question, and it's from Telena Marco, and they want to know, what is your favorite part of your job?
Being out on the job site. I spend a lot of time behind the computer. Half the time out in the computer, the other half getting out in the job site and getting dirty, and talking to the guys is something to me that I enjoy. And obviously the drone. Everybody loves drones. It's fun.
That's awesome. And so I had another follow-up question. So you've mentioned like leveraging all of this emerging technology in your projects. How did you communicate that vision to different stakeholders, especially when you were first adopting it? How did you persuade people to give this a shot and eventually integrate it with what was
Yeah, well, we had to prove it. And we had to prove it to ourselves, first. So there was a handful of us, other field engineers that, all had the opportunity to take the equipment out and do these designs and come back out and install them. And once the stakeholders and owners seen that, hey, we can save a lot of money. We could spend a little bit more money up front, but then, we save it later in the end, because it gets installed, the first time, correctly. And there's not errors or measurements that were pulled wrong. And there's a lot of people that don't want to change. And unfortunately, the proof's in the pudding. And once they see that, hey, we're saving money, they have to change.
Definitely. I think technology is a great driver for efficiency. So from your experience as a field engineer, what is the most surprising piece of knowledge that you can think of that not many people know of?
Ah, um, so one thing, a lot of the kids might not know, some of them I'm sure have drones and, might get a drone for Christmas and, get excited to fly it and uh, uh, at a fun level, if you're just using a drone for fun and recreation, you don't need a license. But the minute that you want to use it for work and that you're going to actually use it and make money by doing something with the drone, you have to have a license. You have to have an FAA pilot's license to fly it. Um, so that's one thing. Something else with the drone that's most people might not know is that we can pre-plan our flights so that when we go out to a job site, the drone can fly totally autonomous. So, we launch the drone off, we tell it, hey, this is the mission that you're going to go fly, and basically just stand back and watch and make sure it's doing it. And at that point, it's flying its own route, making its turns, taking pictures, and everything's already programmed ahead of time. So it's doing it itself. It's doing its own job.
And when you're pre-planning the flight, is there like a programming language you're using? Like, how does that work?
Yeah, there's a lot of different programs out there. There's some that can recognize changes in elevations. So as you're flying and you're coming up to a building, it'll recognize that there's something that's 20 feet high, and it'll automatically adjust and go up higher to avoid hitting that building. So yeah, there's every one of these instruments has its own piece of software. Several of them. We have software for connecting to satellites, so that the drone's connected to a satellite, so it knows its fixed position all the time. We have software to register our laser scans. We have software to find our points for the points that we want to lay out later in the piping system. So it's and they're forever changing. As soon as you think that you have one figured out, then they want to update it, and it's something new, and you constantly have to be reteaching yourself how to do some of these things.
So I'm curious, what is the most challenging project you've worked on and why?
uh, so probably the most challenging one was actually not that long ago.
Okay.
There's a steel mill that I was sent down to scan a furnace that's used to melt metals that are used in jet engines. So the facility was having issues with the inside of the furnace and wanted to rebuild it. So we went down, we scanned it, and we brought the scan data back to our design team. They started working on an idea of how to cut this furnace apart and rebuild it and put new pieces in, and which pieces go first, and all of these different angles. So there was pipes coming in on 10-degree angles, and the furnace was round, so everything had circumferences, and it was kind of it was a pretty challenging project, and I was a little bit scared of it because I knew that this furnace makes the company millions of dollars, and every day that it's shut down, it's costing them a lot of money. So it was pretty stressful to say, okay, all right, we're going to design it, and then we're also going to go down and we're going to do the work, and we're going to cut your furnace all apart, and we're going to rebuild it. So once we had all of the design done, they sent me back down to the job site to oversee and make sure that it all went right. So, from start to finish, we scanned it, did the drawings, did the scope of work on how we were going to do it, and then we had to make sure that it went right and see it through to the end. So in the end, it went well, and we were able to get the job done, a couple days early. And hey, a couple of days early from using this technology just saved the plant, $500,000 because every day they're shut down, they're losing money. So we were able to get them back up early and save them money. So, but at the end of the day, it was like I was down there on the job, and I just felt like, you can't come home until you're done. Like make sure that it gets done right. And a little scary.
How important is teamwork in a project like that?
Oh, it's super, super important. And we have a great group of guys, behind us. So being out in the field is challenging enough sometimes. And to have, guys, in your back pocket that you can just call, when you need them to help you pull a measurement or help you spit out a drawing. There's a whole group of guys that have to trust each other uh, and, and and it's knowing who to call. It's knowing the right team members. Do you have a problem with a timesheet, or do you have a problem with a design, or so there's a whole group of people behind us.
So we have a question from Miss Roberts' class, and they wanted to know, did you have any mentors who inspired your career?
Well, yeah. So oddly, my father was a pipe fitter, a welder pipe fitter. I had two uncles that were all pipe fitters, and I have a son that's a pipe fitter. So my mentor was my father. He got me into the piping trade, and then along the way, there's been a handful of guys that I worked for that helped me get to gave me the opportunities to have this position.
I think one thing I keep noticing is that your work involves a lot of working with people, trusting them, and so it's great how you've been able to share all of those experiences about collaboration and learning from others. So I had another question. How has your line of work changed with demands for sustainability?
So since I've been in the trade, when we first started, laser scanners weren't even wasn't even a thought. Using
Mhm.
drones out on a construction site wasn't even a thought. In fact, I don't know that even drones were readily on the market, 20, 30 years ago. So at that point, and we still use tape measures and levels and all of that. But years ago, that was all you had was tape measures, levels. And years ago, guys needed to know how to figure out all of these offsets and measurements, all in the back of their head. They had to knowledge to remember how to do all these formulas to figure this stuff out. And nowadays, some of that's starting to get lost because we use the computers. So if I need to figure out an offset and a measurement, I'm opening up my computer and looking it up and pulling measurements. So it's quicker, it's more accurate now, but that's been the biggest change, is going from the old school tape measures and levels to now using scanners and drones.
And this is my favorite question. In what ways do you think your job encourages you to be a change maker?
uh, it encourages me to be a change maker, just by having the will to want to do things better, and determination to figure things out.
Mhm.
uh, a lot of the equipment that we got, there's we're the first ones in the company to try to implement it and make it work. So the uh, determination to make it succeed is really what keeps you moving.
Yeah, for sure. I can imagine like when you're breaking new ground, how much learning and determination that probably takes. So thank you for sharing that. And in thinking of students joining us today and in the future, what is one piece of advice that you would want to give to your younger self?
Um, just not to give up. Keep an open mind on things. I never thought that I'd be doing the things that I'm doing, today. So keeping an open mind and uh, ready to do whatever it takes to do a job. when I was early on the career, my dad was a welder, so I didn't know how to weld, but I didn't tell anybody I didn't know how to weld. And guys would come up and be like, "Hey," my dad's name was Ducky. He's like, "Hey, Ducky's son, we need you to weld this bracket, or we need you to weld this pipe. You know how to weld?" I'm like, "Oh yeah, sure." I didn't, but you just go with it, and after time, you learn the hard way and figure it out. So, uh, yeah, keeping an open mind and not turning away from a challenge.
And when you were in middle school, what did you want to be when you grew up?
In middle school, so in middle school, I wanted to be I love playing hockey. So I was young. I always thought I'd be a professional hockey player, but I guess I was just never good enough to get paid for it. So, uh, I always liked building, model cars and building stuff with Legos when I was a kid. So, the job that I'm doing now is kind of fits that. Still building stuff.
And what is one skill that technicians and engineers of the future should develop?
Um, Probably organizational skills is one that comes to mind. It's something that you use, in any field, any practice. Being organized, whether it's with your tools or your computer folders or kitchen cabinets. It's a key part of being successful. So yeah, organization.
And I think that's really reflected in all the projects you described. Just when you're like in a leadership position, being able to like manage the project, I think you really highlighted that. So thank you for that. And now we're going to move on to some fun questions. So fill in the blank of this sentence. I am, and then you can finish that sentence with one word to describe yourself.
Okay, determined.
Awesome. And what is your favorite hardware, software, or any piece of technology?
The drone. The drone's always fun.
Yeah, I think our viewers would also probably agree.
Yeah.
What do you like to do for fun outside of work?
So I'm married. I have three kids. Outside of work, I love going out to dinner with my wife. And all my boys, they all like to hunt, fish, golf, play hockey. So hey, all those recreational stuff. You know, we get involved with.
And if you could have any superpower, what would you choose and why?
Uh, I would want to be able to see into the future. I
Yeah.
think that would be a really cool superpower, to be able to look ahead and make sure you're making the right decisions. Probably also play the lottery a little bit more.
What's something you've done in your life that you're really proud of?
uh, Raising my kids. I got three young men that two of them are grown adults. All with successful careers. And my youngest one's just finishing up college. Maybe end up doing something like I do now.
Awesome. And last question, what is a skill that you haven't quite yet mastered but would like to?
Oh, there's lots of them. There's lots of skills. Almost every aspect of my job is a skill that I can't say that I mastered. So with the work that I do, we have so many different pieces of equipment that we use. So getting great at any one of them is, always opportunity to get better at any of them. You're good at all of them, maybe not great at any of them. So it, in golf, I wish I was a better golfer.
I played golf too in high school, and
Oh
it's
yeah,
a difficult game.
yeah.
Yeah. Well, I believe that's all the questions we have time for today. I do want to take the opportunity, Jay, to thank you so much for joining us. I've learned a lot. I'm sure our viewers learned a lot, especially how you've mentioned being determined and just staying committed to learning. You talk about how you're using all this technology, and that takes a lot of learning, unlearning, relearning. So it's really great to hear your experience about all of that and your passions. So thank you so much.
Yeah. Thank you for the opportunity.
And we
Just
also Oh, thank you. And we also want to thank the Society of Mining, Metallurgy, and Exploration for partnering us with today, and our chat sponsors, Bechtel, NCEES, and TE Connectivity. And a huge thanks to all of you for tuning in. To learn more, go to Discover Engineering's website at discovery.org, click on STEM careers, and check out metallurgical engineering careers. We hope you all enjoy the holiday season. Be sure to join us for our next Chats with Changemakers on Thursday, January 25th, when we will partner with the National Society of Black Engineers. Thank you and see you next time.